Welcome you all in the second part of this video of dams and reservoirs. So in previous video we have discussed about reservoirs, right? And this video explain you about dams, right? So in this video we will discuss about the types of dam, the comparison like advantages and disadvantages of dam, the site suitable for dam site selection and the failure of dams. Let's see. A dam is a barrier or a large impounding structure designed and constructed on a water course, means river, to confine large volume of water and then control the flow of water. So dam is nothing but a barrier, right, of some construction material. And why it is constructed? It is constructed to store water on its upstream side, right? So for storage of water, one barrier is constructed on river, which is known as dam. It will retain water at the upstream side of the structure, right? A reservoir is the water retained by such a huge structure. So by constructing dam, reservoir is created at upstream of dam which store water. A dam is an artificially created barrier that impounds surface water derived from a small or a large catchment. It may be also a subsurface dam to store underground water. The mass of river stored at upstream side of the dam is called as reservoir. So this slide explains you all about what is dam, what is its purpose and what is reservoir. So I hope it is clear. Reservoirs are created by dams, not only control flood but also provide water for several human activities. They are irrigation, human consumptions, industrial use, aquaculture, recreation, power generation, and navigability. Hydropower is often used in conjunction with dams to generate electricity. A dam can also be used to collect and store water, which can be eventually distributed between locations through canals or pipelines. So these are the use of stored water by reservoir and dams. So dams generally serve the primary purpose of retaining water, while other structures such as floodgates or levees are used to manage or prevent water flow into specific land regions. So there are many hydraulic structures out of which dams are primarily constructed to retain water. Okay, let's see the in general the advantages of dam. Dams provide Advantages provided by dams include water supply for drinking, irrigation, industrial uses, flood control, recreation and navigation. At the same time, dams also present a risk of public safety because huge area may get submerged due to uncertain reasons of dam failure. So large area of submergence is there, which is one of the risk factor of dam. Man-made dams are typically classified according to their size, intended purpose or structures. Dams provide a wide range of economic, environmental and social benefits. The following are the major benefits. So in general we will discuss about the benefits of dam. First is water storage. So dam creates reservoir that supply water for many uses, and there are many uses that we have already seen in the chapter of reservoir. Irrigation purpose, so that stored water can be mostly used for irrigation purpose. Electric power generation, hydropower plant is constructed along with dam, and thereby we can with the help of hydraulic energy or energy of water, kinematic energy of water can be used to generate electricity. Recreational purpose like boating, camping, etc. Flood control, one of the major, we can say, benefit of dam. So in addition to helping farmers, dam also prevent the loss of life and property caused by flooding, right? Debris dam, the dams provided enhance the environmental protections, right? and it can be used for inland navigation purpose. Let's see briefly the components of dam. Before viewing this slide, let's see one more slide which include the component of dams with figure. This is typical cross section of concrete dam, right? This is concrete dam cross section. So starting from the top of the dam, we can see one is the crest. Crest is the highest level. Let's come below. The upstream portion edge of the dam is known as hill, and the downstream edge is known as toe. So this typical concrete cross section, this triangle top portion is known as crest, the upstream edge is known as hill, and the downstream side edge is known as toe. Right? Now, within the dam section, two openings are there. One is spillway and second is gallery. So spillway is the lower level outlet within the dam body, right? To sometimes pass the water from the reservoir. While gallery is different thing. It is opening within the dam along the length of the dam for different purposes, like for seepage purpose, for maintenance purpose, for some electrification purpose, etc. Openings are provided. So sluice way sluice way is the opening along the width. And galleries are the opening along the length, right? Fine. The other component is spillway. So here see the lines. Actually sluice way is shown with dotted line. So these are the opening, while spillway is not the opening or anything within the dam section. It is another construction parallel to the dam, right? And spillway is the overflowing section of dam. It is a part of dam of at lower height. Okay, so water from the upstream side get flow over the spillway and go to the downstream portion. Other components are or the levels in the reservoir, like we have already discussed in reservoir PPT, like maximum water level, normal water level, freeboard is the top portion of the dam or in the reservoir is kept open, right? And okay, so these are the components of dam. Let's see the previous slide. So hill is the contact with the ground on the upstream side and toe on the downstream side. So bottommost portion of the dam on its upstream is known as hill. Bottommost portion of the dam on its downstream side, and both are in contact with the ground, are known as hill and toe respectively. Abutment are the sides of the valley on which the structure of the dam rests. So for the protection, the sides of the or the banks of the river section is conformed with abutments. Galleries are small rooms like structure left within the dam for checking operations like seepage, electrification, or etc. Diversion tunnels are the tunnels constructed for diverting water before the construction of dam. This help in keeping the river bed dry. So this is diversion tunnels are different structure apart from dam structure. Spillways are the arrangement near the top of the dam to release the excess water that we have already discussed. Spillways are constructed along with dam at lower height and it release the excess flood water from reservoir to the downstream side. Sluice way is an opening in the dam near the ground level which is used to clear the silt accumulation in reservoir site. So lower level opening within the dam is known as sluice way. And crest is the highermost level of the dam. So if you want to describe the components of the dam, you have to draw this figure of gravity dam. Because gravity dam having all the components while earthen dam may not having some components like galleries and sluice way. That's why. Classification of dam. Oh, there are many classification of dam because we have many types of dams. So let's see one by one. So dams classified based on purpose: storage dam, impounding dam, detention dam, diversion dam, coffer dam, debris dam. You have to remember the figures. Actually, dams classification is a huge topic. Okay, so first we will see based on purpose. For what purpose the dam is constructed? So for storage purpose, for detention, diversion, then coffer dam and debris dam. Let's see one by one. First, storage. So as the name said, the main function of the dam is to store water for different purpose. If it is for single purpose, then single purpose reservoir, single purpose dam. Right? So during dry period or during excess demand, the stored water in the reservoir can be utilized for different purposes, say for water supply, for irrigation, for power generation, etc. Detention dam. It is preliminary constructed for temporary to detain a part of flood water. At the time of flood, if heavy flood is there, then that excess some water, a part of the flood water is stored and gradually released. So for detention of flood water, the dam is constructed. Diversion, for divert the water from the river to the channel. For that purpose, a small height dam is constructed. Okay, these different types of dams are of varying height. Like diversion dam, the only purpose is to divert the water. So it may be of 2-3 meter height or 2 meter height dam, right? Likewise. Coffer dam, it is a temporary dam. Okay, let's see the figure first. This is coffer dam figure. So what is the function? Okay, this is coffer dam. Okay, it is a temporary dam constructed to exclude water from the specific area. So it stop water. Okay, to stop water for specific purpose. It is constructed on the upstream side of the site where a dam is to be constructed so that the site is dry. So this coffer dam control the entry of water at the construction site. In this case, it behaves like a diversion dam. Clear? Debris dam. It is constructed to catch and retain the debris. So the function of debris dam is just to retain the debris. Then the height may be 1 meter, 1.5 meter, like that. But still, it is a dam. So please remember, dam is the type of dam is not always the huge structure. It may be a 2 meter height, 3 meter height, but it is a barrier. That's why it is called dam. Clear? Fine. This is one of the actual figure of coffer dam. Next classification based on hydraulic design. Hydraulic design purpose, the dams are of two types: overflow or overfall dam and non-overflow dam. As the name says, overflow. So it is constructed with a crest to permit overflow surplus water. So if the height of the dam is low, and if the flood occur, then the flood water may flow over the crest of the dam and then flow downstream. So generally dams are not designed as an overflow dam for its entire length. Diversion weir of small height may be designed to permit overflow. So small height dam, one of the name of small height dam is weir. So generally weirs are overflowing section. Large height dam section generally not designed as an overflow dam. Non-overflow, it is constructed such that water is not allowed to overflow over the crest, right? So in most cases dams are so designed that part of its length is designed as an overflow while the rest of length is designed as non-overflow. This is important point. And that portion of dam over which the water overtop is known as spillway. Okay, please hear this all the sentences, and please carefully read these sentences. You can easily get the idea what is spillway, what is dam, what is weir. In some cases these two sections are not combined, like in case of gravity dam, concrete dam, the height is very high, so it is not possible to make it overflow dam. So within the dam section or parallel to the dam, spillway is constructed and the excess flood water overtop from the spillway, not from the dam body. Now, in case of earthen dam is made up of earth material. So it is never designed as overflow dam. If water overtop from the earthen dam, it may flush out the dam body. So in case of earthen dam, it is always constructed as a non-overflow dam, and if flood occur, then the excess flood water may diverted into another structure called spillway, which is constructed away from the dam section. Okay, so this is one simple figure of non-overflow dam, overflow dam, right? So free body is provided for non-overflow dam. Extra space is provided to uh, accumulate or to collect the extra flood water. Next, based on material of construction. This is important classification of dam based on material of construction. Rigid dam. It is constructed with rigid material. Rigid means solid material like stone, masonry, concrete, steel, timber. Steel dams and timber dams supported on like steel framing or the wooden framework are constructed only for small heights, rarely constructed. Usually dams are constructed with concrete, masonry and stone. So rigid, constructed with rigid material. Non-rigid, it is constructed with non-rigid material like earth, like soil, rocks fill, tailings. So these are few examples. We will later discuss in detail about these types of dam, but this is briefly classification in terms of rigidity, right? Material. So rigid like concrete, masonry, non-rigid like earth, rock fill. So one type of dam, non-rigid dam is earthen dam. So it is made up of gravel, sand, combination of these materials. Tailing dams made up of waste or refuse obtained from mines. Rock fill made up of rock and watertight material. Rock fill composite, it is made up of earth plus rock. Earthen dams made up with stone masonries or concrete overflow sections, right? Composite dams. So in some case, part of length of dam is constructed as earth dam and the rest as masonry is known as masonry cum earth dam, right? Composite dam. So this is the one figure which to explain you the cross section of earth dam, how it look like, rock fill dam and combined rock and earth fill dam. We will see this or discuss this figure in later section in detail with embankment and dam, right? Dam classification based on structure. Now again this is important, structure. Based on structure and material used, dams are classified easily created without materials. Gravity dam, embankment dams and masonry dams with several subtypes. Let's see arch dam. It is curved masonry or concrete dam, convex upstream, which resists the force acting on it by arch action. The only arch dam in India is the Idiki Dam, double curvature in plan. It is concrete arch dam. So arch dam is generally made up of concrete. This is typical view of arch dam, cross section and top view. Arch shape. The arch shape give good strength to these type of dams. They consume less material. They are very narrow sides. They need strong abutments. These type of dams are concrete or masonry dams which are curved or convex upstream in plane. This shape helps to transmit the major part of the water load to the abutment. Arch dams are built across narrow, deep river gorge, but now in recent years they have been considered even for little wider valleys due to advance in technology and material. Good for narrow rocky location. They are curved and the natural shape of the arch hold back the water in the reservoir. Arch dam like the El Adzar Dam in Spain are thin and require less material than any other type of dam. So main advantage of arch dam is the requirement of material. It is very thin. But the main precautions or we can say disadvantage is the construction of arch section. It required good techniques and skill work. Otherwise, it may cause failure or cracking in the structure. Next and the most important dam is gravity dam. In which category? Structure category. It is a masonry or concrete dam which resists the forces acting on it by its own weight. Why it is called gravity? Because all the forces acting on the dam are resisted by its own weight. That's why it is known as gravity dam, and it is made up of concrete. Its cross section is approximately triangular in shape. Straight gravity dam is straight in plane. Curved gravity dam is curved in plane, right? So this is typical cross section of gravity dam which I have already show you in the elements of dam. So this is of triangular shape, having galleries within the dam body and having 3 points, crest, heel and toe. The portion of the dam or the part of the river before dam is known as upstream and that face of dam is known as upstream face, and the portion of the dam or the river before, sorry, after dam is known as downstream portion of the river, and that face of dam is known as downstream face. So this is original figure of Sardar Sarovar Dam, which is the best, I can say, gravity dam in India. Solid gravity dam, it consists of solid mass of masonry or concrete. Hollow gravity dam, it has hollow spaces within the body. Most gravity dam are straight solid gravity dam. The concrete gravity dam holds dam in place. Lots of concrete is required. It is very expensive. These dams are heavy and massive wall-like structure of concrete in which the whole weight acts vertically downwards. As the entire load is transmitted on this small area of foundation, such dams are constructed where rocks are competent and stable. So it required very huge and strong, solid foundation, rocky foundation. Bakra Dam is the highest concrete gravity dam in Asia and the second highest in the world. Bakra Dam is across river Satluj in Himachal Pradesh. The construction of this project was started in 1948 and was completed in 1963. It is 740 feet high above the deepest foundation. This is the view of Pakranangal Dam. See the cross section. It is the narrowest section, the best site for construction of dam. It is concrete gravity dam with spillway at the center. This is the spillway section, right? See, we have already seen that whole section of dam is never constructed as a overflow section, right? So this section is overflowing section and gated structure. So this is spillway, straight drop spillway. We will see it later. So this is highest gravity dam, Bakranangal Dam. Next, arch gravity dam means mixed composition of gravity dam with arch. Next, buttress dam. It consists of water retaining sloping membrane or deck on the upstream which is supported by a series of buttresses. Let's see the figure. These buttresses are in the form of equally spaced triangular masonry or reinforced concrete walls or counterforts. Let's see the figure first. See, this is buttress dam, two type, deck type and multiple arch type. So buttress dam consists of a deck, or we can say slab, and these piers, or we can say buttresses, two portion, and combination with these two, the whole section is look like this. This is top view. So if the deck slab is of arch shape, then it is known as multiple arch buttress dam, right? So here in case of buttress dam, at the downstream side we can store few amount of water. Okay. So it consists of concrete slab and the piers or buttresses. If the deck slab is of flat shape, then it is bulkhead buttress dam, and it is of curved shape, then it is multiple arch buttress dam. So generally the buttress dam is behave like a gravity dam, right? Okay, this is one of the figure of buttress dam, 3D view and original view of buttress dam, right? The top portion of all type of gravity dam can be used as a road or connectivity from one side to another side. So this is buttress dam. Now next, dam classification based on structure. Small height dam which are known as wear and barrage. Here I directly show you the comparison between wear and barrage. Before this, let's see the figure. So what we can see, there are many components we can see over here, but the uh, this is the cross section. First I would like to say this is the cross section of two barriers. Where is the barrier? 1 and 2. What is the function? We are we are discussing about the dam. So these are the dams, right? So what is the function? They store water on its upstream. How? By constructing these barriers. What you will see in these two barriers construction? See, in this figure, this is the construction, or this figure show you the gate, and this is nothing but the wall, right? So this is the basic difference, or how we will bifurcate, or how we will identify that what is wear and what is barrage. Just you have to remember this one thing: barrage is a gated structure and the water stored by the gates only, while wear is usually non-gated structure and the water stored on its upstream is done by weir wall. So barrage and weir are the small height dams, and the water storage or ponding is done by the gates in case of barrage and by the weir wall in case of weir. So for wear and barrage difference, just you have to keep in mind the figure, this figure, and these are the provisions for like construction purpose provision are this is the concrete slab which is constructed for stability of this small structure, and the protection of the concrete slab, we have to provide the protection works like uh, rock filling, etc., right? Let's see the difference between wear and barrage. So let's see first difference: barrage, low set crest. See, crest is the highest level of the dam or barrier, right? So low crest, because whatever be the height of gate is equal to height of barrage, while in case of wear, whatever be the height of this wall is equal to height of barrage. So gate height is limited, right? So barrage crest level is low compared to wear, right? So barrage low set crest, wear high set crest. Ponding is done by means of gates, obviously, while over here the ponding is done against the raised crest, or partially against the crest and partially by shutters. So in weir, sometimes to get more storage, shutters are provided, right? That's why sometimes weir is constructed with weir wall with shutters. Third point, gated over entire length, barrage, right? Shutter in part length. Gates are of greater height, shutter are of smaller height. Gates are raised clear of the high floor to pass over it, shutters are dropped to pass through. So the perfect control on river flow in case of barrage, because we can control the flood water by operating the gates, while if we first we fix the weir wall height, we never change the wall dimension. So the no control of river in low flow. Gates convenient to operate. Operation of shutter is slow, right? High flood can be passed with minimum efflux, while in case of wear, excessive efflux in high flood, because we are having the fixed wall. less silting upstream due to low shed crest, and again the barrage is always operated with gate, so the silting problem is always eliminated in case of barrage, while in case of weir it is wall construction, so silt is always accumulate at the upstream of the weir. Longer construction period in case of barrage, in case of weir shorter construction period. Silt removal is done through undersluices, while in case of weir no means for silt disposal. Uh, Road or rail bridge can be constructed at low cost. No possible to provide bridge. Costly structure. While it is weir is cheaper, because operation of gates is always there in case of barrage. Right? So this is small topic. Barrage and weir both are small height dams. Now dams classification based on structures. Another classification are these are the earth dam of trapezoidal shape. Earth dam are constructed where the foundation or the underlying materials or rocks are weak to support the masonry dam. Earthen dam are relatively smaller height and broad at the base. They are mainly built with clay, sand, gravel, hence they are also known as earth-fill dam or rock-fill dam. Right? So another classification based on structure is embankment dam or earth-fill rock-fill dam. Embankment dams are also armed with dense waterproof core that prevent water from seeping through the structures. It is a non-rigid dam which resists the forces acting on it by its shear strength. Its structural behavior is in many ways different from that of gravity dam. It is totally different from gravity dam. Now let's see this figure again. First figure show you earth dam. This is typical cross section of earth dam, and for stability purpose, because it is made up of locally available earth, so and it is always contact with the water on its upstream, so for stability purpose the impervious core is constructed at the center, and this is the earthen material which is pervious. So for stability of this slope and the material, slope protection work is provided on its upstream, and at the downstream for the protection of the dam body, rock toe is provided. Horizontal filters are provided to filter out or to seep the seepage water. Right? So this is the typical cross section or construction of earthen dam. Another is rock-fill dam. So rock-fill dam is constructed like this. It is divided into two, I can say, section on for like half portion or some portion with masonry and some portion with rock. And for the stability and seepage other purposes, impervious membrane is provided at the upstream, because upstream portion is always in contact with water. This is the combined rock and earth fill dam with particular slope value, and on its upstream the protection of the slope riprap means stone stackings and other provisions are provided for slope protection. So this is the typical cross sections of embankment dam, earthen dam, rock fill dam and combined dam. Okay, based on material, steel dam and timber dam, which are not nowadays not used in construction. There are many ways in which the natural lakes and the dams can form in nature. Natural dams have many economical benefit, including hydropower generation and recreation, but also can consist serious hazards. Naturally, the geological formation is there. Natural dams are formed, right? So, in the last 100 year, a number of catastrophic events associated with rock slide, dam formation, and failure have occurred in the mountain region in the world. Most of them happen in the natural dams only. So natural dam may cause upstream flooding as the lake rises, and downstream flooding as a result of failure of the dam. So natural dam are, I can say, hazardous in terms of natural phenomena. So this are the classification, I can broad classification of dam. Just you have to remember the figure and write up once, that based on structural behavior, based on material, these are the types of dam. I will discuss the advantages and other topic in my next video. Thank you. Let's see the advantages and disadvantages of different types of dams, like embankment dam, advantages and disadvantages. So embankment dam advantages are: an earth dam can be constructed almost on all type of available foundation, right? Unskilled laborers also can be employed in the construction. The cost of construction is less compared to rigid dam, and it can be constructed in short time period. So earthfill and rockfill dams are very easy to construct, can be constructed on I can say sandy or soily foundation, and the cost of construction is less. So these are the disadvantage. And earth dam cannot be constructed as overflow dam, right? Main problem. And spillway has to be located away from them, so we have to construct spillway on another site apart from them. The maintenance cost is very high. It required constant supervision. It fails by floods suddenly without sufficient warning time. And earth dams are not suitable for narrow gorge with steep slope. So these are some disadvantages of earthen dam on gravity dam comparison. Let's see the advantages of gravity dam, or we can say concrete dam. Gravity dam are most strong and durable than earth dam, obviously. Gravity dam can be constructed of any height, suitable foundation, and should be available. It required less maintenance, right? The failure of dam, if any, is not sudden. So we get prior intimation. A gravity dam is cheaper in long run. The benefit cost ratio is always high. So advantages are great or benefit are great in terms of earthen dam. So what are the disadvantages? Gravity dams constructed required sound rock foundation. The initial cost of gravity dam is always higher than the earthen dam. Mechanized plant for manufacturing and transporting concrete are required. So these are the, we can say, constraint of gravity dam. Let's see the causes of failure of dam. Dam failures are of particular concern because the failure of a large dam has the potential to cause more death and destruction than the failure of any other man-made structure, because the structure is huge and it carry water on its upstream. So this is because of the destructive power of the flood wave that could be released by the sudden collapse of large dam. In general, a failure results in the release of large quantity of water, right? The failure of our dam may be due to hydraulic, seepage, and structural failures. The following are some of the reasons of dam failure: are overtopping of embankment dam due to inadequate spillway capacity, or the flood amount is very huge, right? Then it may get overtop and failure of dam occur. Faults in construction methods, then geological problem may be there in the foundation, landslide which fall into the storage reservoir, earthquake can certainly cause damage to the dam. The causes of hydraulic failure may include overtopping, erosion of upstream, erosion of downstream surface, erosion of downstream toe. Seepage failure, structural failure, slip failure in dam, structural failure due to sliding of foundation, damage due to borrowing animal, failure of dam due to earthquake of neotectonic movement, tectonic movement, right? So these are the causes and failures of earthen dam, right? So this is the end of the module dams and reservoir. Thank you.